Welcome to this lecture. We are going to discuss about the diffusion current. Myself Sarana Kumar, Assistant Professor, Department of EEE, Hindustan College of Engineering Technology, Coimbatore. So, content of this lecture: introduction, diffusion in PN junctions, formation of depletion region, establishment of equilibrium, diffusion current under forward bias and reverse bias, applications of diffusion current, and finally conclusion. So let's come to the introduction. In a PN junction, diffusion current arises from the movement of charge carriers, both the electrons and holes, from the region of higher concentration to the region of lower concentration. This current flows due to the concentration gradient across the junction. Specifically, electron diffuse from one side to the another side. So this diffusion current occurs without the influence of an electric external field. So we are not applying any DC source or AC source. Diffusion in PN junctions. At the junctions, the electrons are diffused from N-type region to the P-type region, and holes are diffusing from P-type region to the N-type region. This diffusion leads to the formation of depletion region in the PN junction. Formation of depletion region. So depletion is nothing but the recombination of electrons and holes near the junction. We are connecting a P-type substrate and N-type substrate. It will create a recombination of holes and electrons. This region is called as a depletion region. An electric field develops across this junction, this region, opposing the further diffusion process. Let's come to the establishment of equilibrium. Initial diffusion creates an electric field opposing further carrier movement in the diffusion process. The drift current is nothing but if you are applying an electric field, the electrons are drifted towards the positive terminal, that is called a drift current. This current causes by the electric field balances the diffusion current. So equilibrium is achieved when the diffusion current and the drift current are equal and opposite. Now the diffusion current under forward bias. So we know the forward bias. When the forward bias P type is a positive and N type side is a negative, diffusion current increases because the applied voltage reduces the potential barrier, allowing more carrier to cross through it. So in this forward bias, as a result, in the significant increase in the diffusion current will takes place. Diffusion current under reverse bias. So in reverse bias, we know the P side is negative and the N side is a positive. The diffusion current reduces the barrier potential increases, and it's hindering the movement of majority carriers. Only the small leakage current flows through the minority carriers. Applications. These diffusion current will be applicable in all solid state devices such as diodes, transistors, and it will also play a vital key role in the operation of solar cell, that is a photovoltaic cells. It influences the behavior of semiconductor device sensors also. Conclusion. Diffusion current arises from carrier concentration gradient in the semiconductors, and it will balance with the drift current to establish equilibrium in PN junctions. So understanding this diffusion current is crucial for designing and analyzing the semiconductor devices operations. Thank you.